So I have been asked to do a video on inverse functions. And so first thing is I'm going to define function. It's a relationship or an expression involving one or more variables. Okay, let's see if I can slide this over. Ooh, cool. Yeah, I'm definitely like figuring things out. Let's insert another one. So that's just what a function is. A lot of times we see this, like we use them to graph linear equations or quadratic equations, whatever. A function just involves one or more variables. It's a relationship. An inverse function, basically, I got a lot of resources online to try to put this lesson together. And I think Khan Academy says it best that inverse functions are functions that reverse each other. So there's that. Drag it. So we have, there's another way to put it is, and I really liked this one. I believe I got this, I guess, analogy or metaphor. I mean, I'm a math teacher. This analogy as in, if we go one direction, let's say we have f of x is going to turn an apple into a banana. So f of x is going to turn an apple into a banana, but then if we have, can I copy this, duplicate this? If we have the inverse function, which is written as, it's to the -1. Can I write that on here? It's not pretty, but I can write it. It's going to go backwards. It's going to turn a banana back into an apple. So f of -1 of x is going to turn that banana back into an apple. Okay? Not the prettiest thing, but you get the idea. So there we have it. There's our definitions. There's kind of an idea of what inverse functions are. Let's look at some examples. So the first example I'm going to pull up is going to be a picture of maps, domain and range maps. Here's a picture of a mapping where we've got the domain on this side, the range on this side. If we start with plugging in the value of a into our original function, we're going to end up with a 3. If we were to go backwards and we were to plug in a 3 into the inverse function, we would get a as our output. So for example, let's do a couple of just, if I were to give you a function, let's say, I don't know what letter that is. If I were to give you f of, let's say, 3, whatever the function is, f of 3 equals 7. Okay, we don't need to know what the equation is. We just know that if we plugged in a 3 to that equation, to that relationship, we would get a 7 out. So if I said, okay, now that you know that information, what is the inverse, f inverse of 7? If we look at the mapping, I mean, we would just go backwards, and so f, the inverse, if we plugged in a 7, we should get a 3 out. So 3 is our answer there. Okay, so for any expression, any function, if I even had h of 5 equals 15, the inverse of that, if I plugged in 15 in the inverse function, we would get a 5 out. If I were to give you something that looks a little like this, a regular function, I'm going to insert the inverse inside of that. I'm going to say, I don't know, the inverse, we'll say 3 is our input. What's technically going to happen here, and I'm going to get a different color for this, is this original function is going to undo the inverse and leave us just with 3. So it's kind of like canceling it out. We're just going to be left with 3. If I did that for anything, if I said m, even if I took the inverse of the regular function of any number, let's say 200, I don't know, I'm just making numbers up, we would end up with 200 still. That is true for any function. So f of the inverse of x is just going to be that number that's inside. Okay, so now I have this next example. We're looking at inverse functions from graphs. So let's say that this is the graph of f of x. Okay, it is an exponential graph. It's growing. Just a little refresh on that. If I were to say, first of all, let's just look at the graph for a second. Let's analyze the graph. I'm going to say, what is the value of f of 1? This number right here is wherever the x coordinate would be. So I'm going to go over here on my graph to the x coordinate, and I see that the x coordinate is 1 right here. So my output, the y coordinate at that point, is going to be 0. I can do that for f of 2. Just some practice here. F of 2, the x coordinate's over here. The y value at f of 2 is going to be 1. So then I would just, if I were to ask you, well, what is the inverse of 1? So then I would say, okay, now I'm going to go backward. I'm going to say, well, now here's where my y value is 1. My x value here is going to be 2. Okay, I can even do that for, f of the inverse of 0. That's going to be 1. So you're looking now at the xy coordinates. What's going to happen is your xy coordinate, they're going to swap places when you're talking about the inverse. So a lot of questions that you might have, like on your assignments or anything like that, you'll get like just a list of points. 5, 4, just a list of points, and it'll say, okay, what's the inverse? You would just swap all those points. 2, 1, 4, 5. We're going to take this idea into creating inverses from equations a little bit later. But first thing we're going to talk about are one-to-one functions. One-to-one functions mean that for every element in the domain, there is exactly one element in the range that matches. So one-to-one. I'm going to use the same graph as the last example here. And there's a way to test that, and you guys may have heard of it. We're going to talk about the vertical. Oh, geez. Sorry about my handwriting. It does get better. We're going to talk about the vertical and horizontal line tests. It's kind of just like it sounds. So the first thing, I'm going to use different colors here. I'm going to say red for vertical. We'll do green for horizontal. So when I do the vertical line test, it's, like it sounds, I'm just going to draw a whole bunch of vertical lines, okay? Not exactly the straightest. But as I go through here, I mean, if they're straight lines, they only hit the graph once. So this line down the middle, almost on the y-axis, supposed to be the y-axis, only hits the graph at one point. It does look like this eventually is going to go straight, but it's getting closer and closer and closer to 0 and won't actually touch it. But this line that I just drew only hits the graph once. Here's 1 point, here's 1 point. So this graph right here passes the vertical line test. So if I were to go through and erase, let me erase this to do the horizontal line test, it's going to be the same idea. We're just doing horizontal lines now. So yours might be way better than mine, but you guys get the idea here. So we've got one point, it only crosses once, it only crosses once, it only crosses once. All of these, this passes the vertical and horizontal line test, so this would be considered a one-to-one function. For an example, if I know that some of my classes we were just talking about quadratics, a quadratic graph looks like this, so that would not be one-to-one, because if I were to go in there and do horizontal line, it would not pass because we've got this one line hit the graph twice. So that's an example of a non-one-to-one function. The next topic is finding the inverse given a function. We talked about looking at the inverse given coordinates, maps, graphs. Now what happens if we were given something just like this? F of x equals 2x plus 3. If you recall a couple examples ago, we ended up just switching the x and the y values on the coordinates. In reality, this f of x right here, this is the output, which on coordinate planes, the y values are the output values. So I'm going to first start off by replacing f of x with just y. So now I have the equation y equals 2x plus 3. Just like we did before, we're just going to swap this y and this x here, and I'm going to rewrite that to now it says x equals 2y plus 3. The goal here is to get back to having y by itself, to solving for y. We're going to undo all of these operations here. So we're going to, instead of add 3, we're going to subtract 3. We have to keep it balanced, so we got to do it to both sides. So we're going to have x minus 3 equals 2 times y. In order to undo this multiplication here, we need to divide by 2. And then we're going to end up with y by itself now. Y equals x minus 3 over 2. So the inverse of this function, the inverse of x, is going to be x minus 3 over 2.